All right, so ladies and gentlemen, we are starting something today called exponential functions. So for the past, I don't know, year and a half almost, you guys have been talking about linear functions. Linear, so let's write this up top. Linear means straight line, right? So a linear function is basically any sort of straight line. That's what we have been drawing and graphing and doing and learning about and doing the equations. Now we are taking a step away from straight lines and we're doing something completely different. We're talking about exponential. So an exponential function basically looks like just like a kind of like a curve. It like looks kind of like a flat line and all of a sudden it curves up. Okay. So some of you might have I don't know, this past year read the news, watched the news, read news articles about this thing that's going on in our life right now. And that's why we all have to wear masks. And a lot of people have been graphing these types of graphs. Like when they show infection rates, they're not showing, a straight line. It's not a straight slope, right? It's like a few people get sick and then boom, all of a sudden, it's like a lot of people get sick. Like, does that kind of like, have you kind of seen graphs that look like this, like on the news and stuff? Maybe. But that's like, I mean, unfortunately, this pandemic is a perfect example of exponential, where it's like one person gets sick, then 7 people, then 20 people. And then all of a sudden, a couple days later, like 300 people have gotten sick, right? That's what exponential means. Okay. Think of it maybe like a roller coaster too, right? Where it's like you're flat, 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 and all of a sudden you're booming up, right? Okay. So exponential is not y equals mx plus b. Exponential is y equals a b to the x. Okay, so a b to the x. So exponential means that you have an exponent, and your exponent is always going to be an x. Okay, like it's going to be a different number every single time. If you have a and b without a symbol in between, then what is the symbol always? Multiply. So just remember, if you don't see a symbol, you're multiplying a times b and then to the x. Okay, so there's a couple rules for something to be exponential, and let me show you my calculator just to show you what I'm talking about, okay? So come on, turn on. All right, so let me just show you an exponential function. So I have, let's say a is 2 times 3 to the x power. I just made up a random problem, okay? A times b to the x. So exponential looks like this. Notice how it's like flat, 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 and then there's boom, there's a curve. Okay, so it says a cannot be 0. Because guess what? If a was 0, isn't like 0 times anything going to be 0? So if I change my a to a 0, you see how now I no longer have an exponential curve? It looks like nothing, right? Because if I multiply anything by 0, I just have 0, right? So that's why a cannot be 0. Another rule is that b cannot be 1. So let's change this to 2. So b, this number b right here cannot be 1, right? Does anyone think they know why this cannot be 1? Luis? It would just be a straight line, right? Because if it's 1 to something power, 1 to the anything power is still 1. So if I changed it to 1, do you see how now it would just be a straight line? Like it changes like the math entirely. And so now I don't have a curve that goes up. Okay. And then finally, the last rule is b has to be greater than 0. So this second number has to be a number bigger than 0, but obviously not 1. Because if it's less than 0, what if I did like a negative number? So negative, I don't know, -2, that's less than 0. So if I made a b to be a negative number, do you see how like I can't even see it? It's not a curve. Because remember what we learned a long time ago, 2 weeks ago? Negative, like it kind of messes up with my exponent, because either it's going to be a positive answer or a negative answer depending on what my exponent is. So it's not going to be consistent. Okay, so that is what we're talking about. Now, let's try numbers 1, 2, and 3. So determine whether the equation represents exponential or not. So remember, exponential is y equals a times b to the x. So this equation has to look like that. So someone in person, can you raise your hand and tell us, yes or no, is this not y equals 9x? Yes or no, is this exponential? What do we think? Someone in person. Yes, Rowan.
No.
And then you have to write y.
Because it is not, has no exponents. It's just not, look. It is linear.
Exactly, it's linear. It's not exponential because there's no exponent in my problem. Okay, so let's take a look at this one then. So it should look like this. Someone online, can you either unmute yourself or type in yes or no? Is this exponential? Someone online.
It is exponential.
Yes. And then why? Because it's in y equals a bx form. Right? It's in the right form. So if it is in the right form, then yes, it is exponential. Good job. All right. Last one. Y equals a times b to the x. All right, someone in person. What do we think about this one? Someone other than Luis. Oh, no, sorry. Someone other than Rowan. Rowan last answer. Reed, what do you think?
Yes or no? Would the one not show up?
So good call. So you're like, wait, there's no number. Well, there's no number. It's an imaginary one. So A could be 1. That's okay. But there's still something you have to consider. Tessa? So it's no because B is less than 0. Remember that rule that we just said? This number B can't be negative. Because like if it's negative, depending on your exponent, like is that going to give you a positive answer or a negative answer? It won't give you something consistent. It just completely depends on your exponent. So that's why no, this is not exponential. Okay, now let's look at a table and decide whether this is linear or exponential. So remember, we had 2 rules. For something to be linear, the rule was that you had a plus or minus pattern. Remember that from many, many, many weeks ago? For something to be linear, you saw a plus or a minus pattern. So if something is exponential, it's not going to be a plus or minus pattern. I'm not going to tell you what it is yet. Maybe we'll try to figure it out. So this is plus 1, plus 1, plus 1. Okay, this one. Does anyone think they know what the pattern is? From 3 to 9 to 27 to 81. 3 times 3 times 3 times 3. Okay, so definitely not linear, right? Because there's no plus or minus pattern. Because this is times, times, times. So is it exponential, do you think? Yes, it actually is. It's exponential. So exponential means there's a multiply pattern. Well, some of you are like, wait, no, this is plus. This is not multiply. Don't worry about the x's. The x's always have to be a plus. Like the x's, you always have to have a pattern, right? So then for this one, we're just looking at the y's. Is there a multiply pattern? So I would say yes, because there's a multiply pattern. So that's the rule. For something to be exponential, you have to have a multiply pattern. Yes, Reed?
What about division?
Good question. Okay, so what about division? Because that actually does make a difference. So let's say I had something like this. You don't need to write it down. But this is actually a really good question. I didn't want to bring it up because I didn't want to confuse you even more, but since Reed asked. Okay, so let's just do divide by 2. Okay, so let's have 150. 50 divided by 2 is 25. 25 divided by 2 is 12.5. Okay, blah, 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 blah. So you can clearly see that my pattern is divide by 2, divide by 2, divide by 2. But I said that exponential means you have to have a multiply pattern. And yes, that's right. You still have to have a multiply pattern. But if you're dividing, can't you change it to a times pattern? If you're dividing by 2, it's the same thing as timesing it by 1/2. Timesing it by 1/2. Timesing it by 1/2. So Reed is saying, can I have a dividing pattern? No, you can't have a dividing pattern. But technically, you can change all division into multiplies. Okay, so when you write it, if it were to ask you what is the pattern, you can't say divide by 2. That would be wrong. You have to say times half, times half, times half. Okay, this one. So it looks like you're adding 1, adding 1, adding 1. So far, so good. Someone online, what do we think? Is this linear or exponential?
Exponential.
So if it's exponential, that means that it has to have a multiply pattern. What are you multiplying by?
It's not exponential.
Yeah, it's not exponential. Do you see how you're adding 2, adding 2, adding 2? So this is actually linear. And you can say because it's linear because there's a plus minus pattern, or you can say it's linear because you have a constant rate of change, something like that. Okay, so just know the difference now, okay? Linear, plus minus pattern, constant rate of change, same thing. Exponential, multiply pattern, multiply pattern, multiply pattern. All right, now it says evaluate. Evaluate always means to solve, okay? Solve it for the given value of x. This is the easiest thing in the world, guys. So they're basically asking you to take this x and plug it in. I really don't want to have to do the math, so why don't I just do it on my calculator? As long as you type it in exactly as you see it, you should be fine. So like I have 2. If they wrote parentheses, make sure you have the parentheses. To the, and then x they told you to plug in as -2. Did someone type that in person, kids? What did we get? Mason? 0.125 is my answer. If you really want to change it to a fraction, sure, you can go alpha y equals, and then the fourth option, f to d, and then hit enter. You can also write 1/8, but honestly, like, as long as it's not repeating, you're good. All right, so try number 7. All you're doing is taking the x and plugging it in. Someone online, can you shout out or can you type in what this answer is? Someone online.
-375.
Thank you. It's -375. That's the only answer. You should be typing it in exactly as you see it with parentheses and everything. Okay. All right. Backside. Now let's graph exponential functions. Oh, and then we have to identify all these things. Y-intercept, asymptote? What does that even mean? And then describe the domain and range. Holy moly. Okay. So let's do that. Let's go ahead and draw ourselves an XY axis. I don't know how to graph this. To be honest, I don't know how to graph it by hand because there's no like slope or, like mx plus b rule. So if you don't know how to do anything, use your calculator because we can use calculators this year. So maybe 2 + 7, 1, 2. Clear your memory first, okay? 2 + 7, 1, 2. Okay. What did you say? 2 + 7, 1, 2, 2 + 7, 1, 2, 2 + 7, 1, 2, 2 + 7, 1, 2, 2 + 7, 1, 2, 2 + 7, 1, 2. All right, so let's type this in. Go to the y equals. You're typing in -2. Don't forget the parentheses. Type it in exactly as you see it to the x power. And remember, the x is right here, right next to alpha. So I'm typing in my equation exactly as I see it. I'm going to hit graph. And boom, that's exponential. Even though it's kind of like the curve is facing the other way, that's okay. As long as it's still a curve like that and not a straight line, then we're good. Okay, so I'm going to hit second and table and I'm going to graph it. So guys, I still want 3 dots pretty much, okay? And these are kind of hard. We might have to estimate a little bit, okay? So I have like 0, -2. I have 1, -1. 2, -0.5. Like, do you see how as long as I kind of have a curve, and you're going to have to say, oh, definitely don't connect those to be a straight line. Make it look like this picture. So then you realize, oh, okay, it looks something like that. Like that's going to be my picture. So you still have to model it to look like the actual picture you see on your screen. Okay, let's do the hard stuff. So the first thing it asks me to do is identify the y-intercept. Does anyone think they know in person? Do you think you know what the y-intercept is? Luis, what do you think? The y-intercept. Yeah, so the y-intercept is always what hits the y-axis, right? If you don't know, go to your table, look for the 0. Oh, 0, -2. So my y-intercept is -2, or you can write 0, -2. Let me give you a hint, okay? This A, this first number is always going to be your y-intercept. So technically, you don't even need to like look at your table. You can just look at your equation and say, oh, that is my y-intercept. All right, now it's asking me for something called asymptote. Yeah, let's talk about that later, okay? Let's do the things that we know. Domain, range. Okay, so we haven't done this in a hot minute. Remember domain? Domain is your x's, range is your y's. Now remember how like if everything is connected into a line, that's when you have your inequalities and your alligators always eat to the right. So I'm just going to set it up. Okay, so domain, my x's from left to right. How far left do you go? You keep going, you keep going, you keep going, you keep going. So how far to the left do you go? Negative infinity. How far to the right do you go? Infinity. So remember how we said if you have infinities on both sides, what do you actually just write? What? I heard like blah, blah, blah.
All real numbers.
Thank you. Whoever said that. Good memory. I know it's been like a month, not even, maybe more than a month. All real numbers. Whenever you have infinities on both sides, it's all real numbers. Okay. Range. Range is up and down. Why? So how far low do you go? Negative infinity. Okay. Here's the hard thing. How far high do you go? Like it kind of looks like it levels off. At what number on the y-axis do you think it pretty much stops giving up? Well, if you look here, like 0.5, no, because it gets even higher than 0.5. So it gets really close to, like this is me moving my decimal backwards 3 times, moving it backwards 4 times, moving it backwards 5 times. You see how it gets really close to just like the 0? So if it gets really close to 0, then it actually never touches the 0. So that's one rule about exponential functions. It never actually touches a 0. So if you have like an infinity on one side, you cross it out and you just rewrite it. But with exponential functions, it doesn't actually touch the 0. And that's the rule that we're going to talk about in like 10 seconds. So my range is just y is less than 0. Okay, so one more thing. So then now it's asking me something about an asymptote. An asymptote, guys, is the number that it gets really close to, but it never actually touches. So this line, what number does it get really close to but never touch? The 0. So your asymptote, whatever. I mean, you can spell it out. You can write ASYM, whatever. Is going to be, it's going to get really close to 0, but never actually touch the 0. But here's the thing, the asymptote isn't a point, it's an actual line. It's this horizontal line. So it gets really close to this line at the 0. And is this line an x equals or a y equals 0? Y equals. Remember how it's always opposite? Like you think it's an x because it's horizontal, so you always have to flip it. It's the y. Okay. So let's do one more, and then we'll finish the last 2 tomorrow in class, okay? So let's talk about this one more time. Let's do this one. This is the last one we're going to do, okay? All right, so let's graph it first. So go back to the y equals negative alpha y equals with your parentheses and everything. Type it in exactly as you see it. Look at your picture so you kind of know how to draw the shape of it. Okay, so it looks like this curve again. But definitely go to your table so you can have 3 distinct points. Okay, so I have 0, comma, -1. Then I have like 1, comma, -1/3. So I'm actually going to go backwards. I'm going to go -1. Like you can honestly choose any 3 points. So I'm just going to choose -1, 0, and then 1. Those are the 3 points I'm going to choose. But you choose whatever ones you want to, because just make sure that you model your picture like this. So it like goes down, slopes really a lot, and then that. Okay, so now let's answer these questions again. The y-intercept, what is it? -1. So how you can look at that is you can look at your table, 0 comma what? Oh, 0 comma -1. Or remember how we said the asymptote or the y-intercept is always that first number? You don't see a number, but you see a negative, so you can stick in a -1 there. That's how my y-intercept is -1. Okay, domain, what do we think? Negative infinity to positive infinity, right? It keeps on going to the left and it keeps on going to the right. So if I have infinities on both sides, what do I write? All real numbers. Okay, my range, how far down do I go? Negative infinity. How far up do I go? To the 0. And if you really don't know, then look at your table again. Do you see how it like goes to -181 to -1 over 243? Like it gets super, super close, right? -1 over 650, blah, blah, blah. So it gets really close to the number 0, but it never actually touches. So if you have infinity on one side, cross it out. And for this one, like only exponentials, it doesn't actually touch the 0. So it's just y is less than 0. Okay, now let's talk about that asymptote again. It gets really close to the 0. And so, but technically, remember, it's not a point, it's a line. So what is this line? Y equals 0. So some of you might be like, will it always be y equals 0? No, it just is right now because we're learning about the basics. But like if I were to take my graph and if I like at the end write +3, do you see how now my asymptote is at the 3? It gets really close to the 3, but never touches. Sure. Okay, so if I were to write like at the end, like let's say -2. Do you see how it gets really close to the -2, but it never actually touches? So my asymptote can change. We're just learning the basics right now. That's why it's mostly always going to be the 0 for today at least. Okay. All right. Don't lose this paper. We're going to finish number 10 and 11 tomorrow, just because I don't want to take up that much more of your time. Okay. So at this time, all of you are going to open up your video notes and start your video notes. You have 17 minutes left in class, okay? 17 minutes, so you have plenty of time to get started. Please listen to the video notes. Do not do it on mute, okay? If you really need headphones, I have headphones that I can gift you if I haven't already gifted you headphones